Okay, hello guys, and welcome to Chapter 4, and specifically, Math 10C Alberta Curriculum. We will be discussing some of the more advanced exponent laws. This video will assume that you already know the basic 7, so, also, be sure to check out Chapter 5, as both of these chapters will be tested together. They are both algebra, so, yeah. Anyway, let's start with Chapter 4 here. So, first thing you're going to need to learn is fractional exponents, and they're not that hard to do. So, we have the base, in this case, the variable b, and the base, or b, is raised to the power of x over y. So this is a fraction, y over x. This is a fractional exponent. And yeah, so we're going to learn how to deal with them. Essentially, you're going to add a radical sign over the base. So base with the radical sign, okay? Next, you're going to take the numerator of the fraction and you're going to raise the base to that exponent. Okay, so in this case, it'll be b to the power of y. Next, we're going to take the denominator of the fraction and we're going to put that as the index of our radical. So this will be the xth root of b to the power of y, okay? Let's try that with actual numbers. So what about 8 to the power of 2 over 3? So what would we do here? Well, first thing, we always write the base. The base stays untouched. Next, we're going to add a radical sign, okay? Now, we're going to look at our fractional exponent right over here. We have the numerator is a 2, so we're going to raise 8 to the power of 2, okay? And our denominator is 3, so we're going to make that the cube root of 8 squared, okay? What's the cube root of 8 squared? Well, we know a few things. We know that 8 squared is actually 64, so that'd be the cube root of 64. And the cube root of 64 is actually equivalent to 4. So 8 to the power of 2/3 is actually 4. Okay. Pretty simple. Now, let's go to negative exponents. These are actually easier in my opinion, and you may find them so. In this case, we have the base. Once again, it is b raised to the power of negative x. Okay, so how do we deal with that? What we need to do is we need to focus on the base, and we're going to take the reciprocal of the base, and then this negative sign disappears. Okay. In this case, b, always, any number, any integer, is always represented over 1. We just don't write that since that's a waste of time. Okay. So we're going to take the reciprocal of b over 1 to the negative x. Okay. So what that will do is we'll have the 1 on top. So 1 over b, our base, our initial base, to the power of x. And that is a positive x, yes. So when you flip, or rather take the reciprocal of the base, you get a positive exponent. Make sure that the exponent stays with the initial base. Don't move it up here randomly. That's not correct, okay? Don't do that. Let's try this with 8 again. Numerical values, 8 to the power of negative 2. Okay, so let's try. Once again, any number or any integer will be always represented as over 1. We just, once again, don't write that. Okay, so what will this be equivalent to? We're going to go 8, or 1 over 8. And as we have it squared here, we are going to keep it squared here. And the negatives are removed. What do we do from there? Well, of course, 8 squared is equivalent to 64. So 8 to the power of negative 2 is 1/64. You could convert that into a decimal, but we're not going to do that in this video. You could use your calculator for that, quite simply. Okay, now, let's go to prime factorization. Okay, so firstly, what is a prime number? A prime number is a number that's only multiples, or only factors, are 1 and itself. So let's go with the number 7. how can you multiply two integers to get the number 7? Well, you could also do, well, you could go 1 and 7. You could also go -1 and -7. But well, they're both a 1 and a 7. We can ignore the negative signs for right now. So 7, we have a prime number, 2 is a prime number, 3 is a prime number, 5 is a prime number, 17 is a prime number, 19. It really goes quite high, and the only way to find out what a prime number is to actually try out whether or not you can, like, let's go with the number 4. The number 4 is 1 times 4, but it can also be 2 times 2, right? So this is a composite number, it is not a prime number. And for prime factorization, we need only prime numbers. So, in other words, we need 81 to be the multiple of any number of prime, or the product of prime numbers, only prime numbers. So we know that 9 times 9 is 81, right? And 9 is 3 times 3 times 3 times 3. Okay, since this is a 9, this is a 9, they multiply together, we get an 81. So the prime factorization of 81 is 3 to the power 4. Okay, so now how do you show whether or not it's a perfect square, a perfect cube, or in this case, its 4th root? Okay, so we're going to find that out right now. Effectively, if a number is a perfect square, you can split up its prime factors into 2 groups equally. Okay, so in this case, 3 is a prime factor, 3, 3, and 3. So can we split those equal into 2 groups? Well, we can. Clearly, we can put a 3 here, a 3 here, a 3 here, and a 3 here. Okay. Of course, they multiply, those multiply, those multiply. It multiplies everywhere. But the point is, it is a perfect square, as we can split all the prime factors into 2 equal groups. Okay. Perfect cubes continue the pattern with 3. Okay. Also note that a perfect square looks like that, perfect cube and 4th root. So the exponent is actually the number of boxes you're going to be spreading the prime factors into. So let's go into the perfect cube. Is 81 a perfect cube? Well, can you divide 4 factors, in this case, into 3 equal groups? Well, that's impossible, right? So it clearly isn't, as if we put a 3 here, a 3 here, a 3 here, we have a leftover 3 that doesn't go anywhere. You can't split that up into 1, since 3 times 3 times 3 to the power, or times 1 to the power of 3 won't give you an 81. That will only give you 27. So in this case, 81 is not a perfect cube, okay, but it is a perfect square. What about its 4th root? So its 4th root would also be written like this. So that would be the 4th root. And once again, this is only for proving your answer. They will ask you to prove on a test. You can actually use your calculator for any of this. So yeah, just these boxes only for proving. Can we split 4 3s up into 4 equal groups? Well, quite clearly we can. That's quite obvious. And there we go. We have, so 81 is a perfect 4th root. Not sure how to exactly say that. And as we know, anything over the 4th root, the 5th root, 6th root, 7th root, anything over that is not going to be possible, as we've used up every single prime factor in this. So in this case, we have 2 per box. In this case, we have 1 per box, and you can't go half per box, right? So in this case, 81 is a perfect square, not a perfect cube, and a 4th root. Now, here's the last thing in chapter 4, and this one is very interesting. They will ask you to prove this on a test. Yeah, so this is all 64s, right? Okay, so we have the square root of 64s, except this one is negative, note that, and the cube root of 64s, this one is negative. So here are some interesting things. What's the square root of 64? Well, that's quite clearly 8. We know that. Okay. What about the square root of negative 64? So quite easily, a square root is a number. In this case, 8 times 8 would be equivalent to 64, right? So that, yeah, we take one of those for the square root. Okay. Yeah, yet, if we, so how would you get two numbers, two of the same number, to multiply into negative 64? That's impossible. If you go negative 8 times negative 8, you're still going to get 64. You're not actually going to get negative 64, since this one needs to be a positive. But then that's not the same number, is it? Okay, so in other words, this is actually not a possible value. Why? As I just explained, you cannot multiply two of the same number to get a negative. It's just outright impossible. Since, think about it, two negative numbers multiplying each other will always equal positive. Two positive numbers multiplying each other will always equal a positive. So there's no way to get a negative with two of the same number when multiplying. So what about cube roots? And this is interesting, and they will make you prove a very similar thing on the test. Cube root of 64 is 4. Okay, that you can do on your calculator if you don't know it. Why? Since we have 4 times 4 times 4 is equivalent to 64. Okay, that's quite simply why it works. What about, and this is very, very interesting, the cube root of negative 64? Well, you'd think it doesn't work, as it doesn't work here. Yet, so here we had two negatives multiplying, which equals a positive, right? But here, we're actually going to have three numbers multiply, right? So let's say we go negative 4 times negative 4 times negative 4. What will that equal? Well, these two are going to equal 16. That's going to equal negative 64. Yeah, so you can do a cube root of a negative number, not a square root unless you're counting imaginary numbers. Point is, you can't do the square root of a negative number. You can do a cube root of a negative number, and so you can't do a fourth root of a negative number, but you can do a fifth root of a negative number, okay? In other words, if the index is an odd number, you can do it, okay? So in this case, cube root of negative 64 is quite obviously negative 4, okay? And that's how you'd prove it. If you need to write an explanation, you'd say that two numbers multiplied cannot possibly, two of the same numbers multiplied cannot possibly equal negative. They can only make a positive. And that three of the same numbers multiplied can potentially equal a negative. So, yeah, that would be chapter 4. And thank you for watching. Check out chapter 5, as that may be quite important as well.